In this video, we're going to calculate how much weight a mass will have if we take it from Earth to Moon. Does the mass change if we go from Earth to the Moon? Let's do that. So as an example, we have an 80 kilogram mass that is on the Earth's surface. And now, what its mass will be and weight will be if we take it to the Moon. So let's try to understand what the mass is. If you look at any matter, any object, the object is made of protons, neutrons, and electrons, right? If you just take any mass, and if you look at, let's say this is a mass here, and this is made of the protons, neutrons, and electrons. And it doesn't matter where you take it. The protons, neutrons, and electrons, the number of protons, neutrons, and electrons will be exactly the same. It won't change. If it is not going to change, the mass is not going to change. So the mass is a universal constant. It doesn't matter where you have measured. The mass will be exactly the same anywhere in the cosmos. So the mass does not change at all. So we got one answer now. The mass will not change even if you take to the moon. So the mass is a universal constant. So everywhere on the earth or everywhere in the cosmos, it will be exactly the same. So the mass on the moon, this is not the mass of the moon. This is the mass of the object on the moon surface, which will be 80 kilogram. And now let's talk about the weight. The weight is, I will start with the equation and then I will talk about what does this mean. The weight of an object, that's the formula, m times g. M times g. And this g is acceleration due to gravity. So let's calculate this one first. The weight, that's the equation, mg. First, we're going to calculate onto the Earth's surface. Onto the Earth's surface, that is 80 times 10, because the acceleration due to gravity on the Earth's surface is 10, and it will be 800 Newton. And now on the moon surface, on the moon, g on the moon, the value is about 10 divided by 6. That's the value. It is 1/6 of the Earth's surface acceleration due to gravity. So it is about 133 Newton, and it has to be 6 times smaller than the weight on the Earth's surface. So the weight does change. Even on the Earth's surface, it does change if you go from equator to polar, or if you go inside, or if you go to a plane that is at a very high. So the weight of an object changes. So what is the weight? The weight is the normal force exerted by the surface onto you. Or in other words, if you simply try to understand, the g value, acceleration due to gravity, is the location dependent, it is the position dependent, it is the height dependent. So for example, if I draw the Earth surface here, now let's say this is the Earth surface, okay, and this is the equator, and that's the pole. At the pole, if you look at the equation for g on the Earth surface, the value of g is gm over r square. So the r, the radius here onto the pole, is slightly smaller. That means acceleration due to gravity will be higher, slightly higher onto the pole compared to the equator. So the g value does change. And also you see here, if you just take to the moon, the mass of the moon and the radius of the moon will change. So the g value will change. That means the weight of the object will change. Okay? And even if you are in an elevator, and in an elevator, if the elevator starts accelerating, your weight would change, because the normal force exerted by the elevator onto your feet will change. So the weight is a vector quantity, and it depends upon the position to position. Okay, so more about weight in another video. So this is it from this video. If you have any question and comments, do not forget to write down in the comment section below. And Do not forget to like, share, and subscribe the channel. Thank you very much.